Hello, everyone. GM. Morning, good afternoon, good evening, good night. Hello. We're moving fast here. We are in the middle of the second week already, starting lesson 7. We stopped for 2 days just to understand the tooling, TypeScript, hard, and all of that. But today we're going to return the track of learning about EVM, learning about solidity, syntax, by coding Ballot.sol in this environment with with uh, unit tests with this script written in TypeScript, and we're going to see how useful it is to use this tool to code, to understand this Ballot.sol. And we are going to see more syntax about solidity, about how the EVM works with this smart contract. We're going to see about mappings, we're going to see about arrays, we're going to see about proposals, all using these tools, the Mocha Test Explorer, the unit tests. So if you had a good lesson 5, a good lesson 6, if you have your system set up there, if you have your dependencies working, your projects working, you can use that to learn about Ballot.sol, and you can use that to learn any other smart contract that you pick. It's going to be your teacher, it's going to be your guide now, okay? Hey, Marco, I see a question. Yes, for these problems, you just need to compile the smart contract, and then you should have it working. Okay, I'm going to go over this slowly today, and we're going to do all of it together with this smart contract called voting Ballot.sol from Solidity by example. Okay, yesterday we did it with the Hello World that we already knew. We did the weekend project with it. We saw the tests there, they were all passing. We saw the syntax. We saw what is VM. We saw how hard can use VM to interact with the hard runtime environment. Okay, we saw the testing structure with Mocha. We saw the assertions with Chai. Okay, now we are going to put all of these to work to understand this smart contract. This smart contract called Ballot.sol. It's not a very useful smart contract, nothing like a DAO, whatever. It is more like a demonstration smart contract. It's not as useful as a hello world that that is good for educational purposes, but you can't do anything useful with it. With this smart contract now, you can register votes. Okay, this ballot, you can have one contract per ballot per voting period, where you would give a short name for each proposal, and then one person, the creator of the contract, will give the right to vote to each address. You can vote, you can vote, you can vote, you can vote. And then these persons can choose to vote or to delegate for someone else to vote. Okay? And then anyone can fetch the information from the smart contract to see who's the winning proposal or not. So we have this smart contract here that is coded already, that is ready, it works, and we're going to study all of this syntax. We're going to study these new things like struct, mappings, arrays here, bytes 32. We're going to study all of that using the tools that we learned in the last 2 lessons, okay? This is the summary for today's lesson. Just that. Tomorrow we move forward for scripts, running operations on-chain, public testnets, and all using TypeScript, using hard, using these scripts. And then I will prepare you for the weekend project that is using with the Ballot, using the Ballot smart contract. Okay. Sounds good. Let's get started by creating a new project. Okay. But instead of going through the whole setup of hot hat again, I'm going to show you a trick. And you gotta pay a lot of attention here, okay? I'm going to create a new folder, project 3. Okay, whatever name you want to give for today's lesson. And instead of doing the npm init and then installing hard hat and all of that, I'm going to copy some specific files, some specific parts from previous projects. Remember, I told that we would use something like a cookie cutter smart contract, sorry, a cookie cutter project structure, and then we would just replicate that like a boilerplate. I'm going to do that with project 2. Okay. We're going to copy all files, everything from here, except the node models and the package lock. Okay. There are these two folders that are artifacts and cache that they are just the compilation results from the past smart contracts. We don't need them, but we can always clean them too. We deselect those. If you copy, it's no harm. But don't copy the node models. If you copy the node models, this is going to take way more time than setting up a project again. If you end up copying the package lock, there's no problem. But pay attention here because some explorers, they don't show hidden files. So mock rc.json, .env, .git ignore, they might be hidden from you. So you gotta go for your settings in Finder if you're using Mac or File Explorer if you're using Windows to see the dot files, the hidden files here. If you have them there, if you can see them all, you're going to select these and you're going to copy all of these and then paste inside your new project. Since you did not copy the node models, you still need to enter here in the terminal, shell, bash, whatever, and you still need to do the installation, npm install, npm I, just this is good, npm install. This is going to create the node models, the package lock.json, and this is way quicker than setting everything from ground up, okay? I still have the smart contracts from yesterday, yes. I still have the test from yesterday, yes. I can just clean it up. Remember, at the end of lesson 5, I suggest that we clean things up. It's just so that we can copy and paste them like this. Okay, so for starting today's lesson and every future lesson, you can do something like that. Just copy the correct files, install it again, and you're good to go. Okay, we're good to go here. Dante, you want to ask something?
Yeah, what was it you hit on in the terminal np install what?
Yeah, npm
Install
install,
what
just
now?
install. Just install, nothing here. This is just recreating the node models, okay? Because if we try to copy the node models folder, it takes a while, like 5 minutes, 10 minutes, depending on your hard drive and all. So if you do like this, it takes 30, 40 seconds, okay, good. And it's way quicker, okay? Good.
Yes.
Browns, all of the warnings and all you can ignore. I see a question here in the chat. Warnings are not a problem for us today, okay? So let me open this in the cursor to show where we are with this right now. This is going to be a copy from the last state of things that we had in the last lesson. So we have this contract hello world.sol here. We have the test hello world here. Okay. Then I gave you the homework to read these. All of these links here might have taken an hour or so, but this is going to be very important for today's lesson. And if I test this here, like npx hard test, it should work. I should see all of the tests passing from what we had yesterday. Okay. So we have 4 passing, 2 failing, because I did implement those 4, did not implement those 2. Okay. This is the current state of things as we have right now. Okay. When I do test, hard test, hard CLI is going to check if I have my smart contracts compiled or no. If I don't have them compiled, it is going to invoke the compilation for me, okay, automatically. This doesn't happen if I test with Mocha Test Explorer, okay? Then you would get the errors. It's important to pay attention to this. Hard CLI is automating this step, but Mocha Test Explorer doesn't know about compiling smart contracts, okay? Any questions here? Okay, I see a question. Let's me. No, but those 2 tests, they are quite equal to the other ones that we have. Like, should change the text correctly. So I copy this thing here, should execute a transfer ownership correctly. But then I just call another function. Instead of calling transfer ownership, I call set text. And then instead of passing an address, I pass my new text, something like this.
I'm asking because I implemented these 2 tests, and once I run all tests together, like from test panel, run all tests together, the last test always fails. So this test I should like rerun
This
just
one
one
here?
without other.
Okay, this one, you just need to change the owner, transfer ownership to set text. And then you don't need this last block of code. And then you can complete it very quickly. Okay, it's not much of a complexity. But if you want feedback on why it's not working out, you can open a GitHub issue, share your code, and I can look there, you know. At any time for anyone, whenever you want to have some look on your code, what's going wrong with your code, you go there for GitHub, open an issue, paste your code there, and I can look at it, okay?
Okay, yeah, it works when I run only this test. But when I run all tests, all 6 tests that we have here, no, 7 tests that we have here, the last test should change text correctly, always fails. And when I run it only this one, it passes. So.
That's interesting. Well, but this is what I'm saying.
Okay,
Share with me with the open an issue, share with me, and then I can have a better look at it, okay? Okay. Sorry about that. So for today's lesson, I need this environment set up with you because we're going to put a new contract here. In fact, we can even delete these. This is why I'm creating new folders every lesson, so we can delete things without losing these files, losing track of the things we're doing. So create a new folder, delete those other contracts and test files just for us to avoid confusions. And we're going to create a new contract for today called Ballot.sol. Okay. I would advise you even to do a cleanup. npx hard clean. Those comments that we had at the end of lesson 5, demonstrated them yesterday. So I clean up. I don't have my artifacts anymore. I don't have anything about hello world. And we have this new file Ballot.sol. Okay. And I'm going to copy this file from the Solidity by example. I'm going to come for this link. I have it in the README too. And I'm going to copy all of this code. Okay. I'm going to paste it here in my Ballot.sol. Do that on your side. I want everyone with this smart contract, Ballot.sol inside your contract. Okay. And we're going to study this smart contract, all of the syntax, and all using the tests. For example, we have this title, voting with the delegation. Okay, good. Ballot is a smart contract for implementing voting with delegation. But then we have this weird thing here, struct. Did we study struct yet? No, didn't see that yet. Address public chairperson. Okay, this we saw. This address public chairperson here at line 21, it is set at the constructor in line, it is defined in line 21 and it is set at the constructor in line 32 as the deployer. It's similar to something else that we saw. Do you remember? Start with an O. Yes, Pedro.
The owner.
It's very similar to the owner. Yes. The chairperson is stored here, is defined at the constructor, and it has privileges. For example, only the owner can give right to vote, only the chairperson can give right to vote. Okay. So this we know. Line 8 to 19, we don't know. Line 21, we know.
How does that relate to message msg.sender and message.sender? Because
This is
the owner and the chairperson. Yeah.
Yeah, the MSG sender of the constructor is the person deploying that smart contract, you see? Whomever is deploying that smart contract becomes the chairperson here, the owner of some sort, okay?
Yeah, so the deployer of the contract, because they're sending that first message, becomes the chairperson, right?
Yes. The person signing the transaction for the deployment of that smart contract is the chairperson. Okay. Latsmir, you have a question too?
Yeah, this global variable MSG, it's global for all blockchains, EVM blockchains. So, for example, on I don't know, Optimism or somewhere else, we will always have this global variable like MSG.
Yes, everything using the EVM would have this transaction property, okay?
And do we have a list of all global variables that we can use in our contracts?
Yeah, do you remember this topic from lesson 4? Here. Lesson 4, we had this, lesson 4, no, sorry, lesson 3. We had exactly this discussion. Blockchain global variable references here.
Sorry,
Remember?
it's my bad.
No worries, a lot of stuff. Not complaining, I'm asking if you remember, and if you say I don't remember, that's not a problem. Don't need to say sorry. So this is the reference for this. Okay. You're going to find a list there. Okay, it's a lot of things to remember, people. Don't feel bad because you don't remember everything. I don't remember everything. I've been teaching that for 5 years. So it's just normal to take time. And this is why I propose all of those exercises and homeworks so that we get practice, okay? When we listen, we only capture like 10, 20% of things. But when we write, when we build something, when we explain something, we learn 70, 80, sometimes 9% of things, okay? This is how our brain works. So it's normal to forget things, don't stress. Those exercises are for that. The homeworks are for that, are for helping you to learn things and remember, okay? I'm here to help. So today we have this exercise with Ballot.sol for us to learn new things, for us to remember this thing with the deployer owner, okay? But we're going to learn about structs, we're going to learn about mappings, we're going to learn about arrays, we're going to learn about byte32, all of that using this exercise, okay? The exercise is going to be your teacher. And by tomorrow, you should understand a bit more of how this smart contract work, how this function give right to vote work, how this function delegate works, how this function vote would work, how this function mini proposals would work, okay, by test. I'm not going to explain that line by line. We're going to test it with the testing script, and the tests are going to explain the things for us, okay? And of course, I'm going to guide you through this, but the discovery process is very important here, okay? So we're going to create a test file, a TypeScript file called Ballot.ts. It doesn't need to have the same name as the contract, okay, people? The test file can have any name that you want. It's not something that is automatically checked or whatever. I'm creating with the same name just for organization purposes, but you feel free, please feel free to name your testing files whatever you want. These smart contracts, it is a good idea to name the file of the smart contract as the same name as you have of the artifact here. It is a very good idea. But for the test, no. The test, you can test a lot of smart contracts together. It's not a big deal. You name it whatever you want. Okay? So we're going to pick this Ballot.ts, and I'm going to start with this coding block. Okay, this is starting structure with a lot of to-dos here. Okay, we're going to start with this coding structure with some things imported that we're going to need down the road, with this array of proposals here that are going to be this list of short names for each option. Why short name? What's a short name? Bob is a short name. Lucas is a short name. Can I call Mateus as a short name? What's the definition for short name here? So we're going to see that. Right now we have just a structure that is defining the test cases that I want to do, the imports, and this array of proposals that I'm defining here. Okay. I'm going to go very slowly so that you can repeat that on your side. You have time for asking questions. Do you understand why we have this structure here? Why not to test everything in a single script? Wouldn't it be easier to read and understand? Like test 1, test 2, test 3, all after the other. Why do we need to create this structure? Do you remember?
Can you repeat the question? What is the question? Which structure?
My question is, why are we creating all of this structure with the describe here and it and now?
Okay, maybe
Wouldn't it be...
Ivan wants to answer, but yeah, I remember from yesterday.
Yes. Ivan or Ivan, maybe. Yeah, you're muted, I guess. I see you speaking. Am I pronouncing your name correctly in one of my attempts? Yeah, I see you speaking, but your mic, I guess, is not picking your audio.
How about now?
Now it's good.
All right. Well, yeah, Ivan,
Okay.
you get used to the changes of the name once you move to another culture or country.
Yeah.
I assume the tests are separate because there can be dependencies between them.
Yes, because they could interfere. Yes, Conrado, you want to add to this answer too?
Is the same example you give to the car and to crash the car first, then you can do the another test.
Exactly. So this
Yeah.
is why we're creating all of those different test scenarios, encapsulated, separated. Like I have some time capsules where I can come forward and back with these tests, you know. They run in separate and I can go back in time. And also this is why we have this complexity of setting up this structure. But we took like 20 minutes to explain that with Mock and Chai. After we explain this structure is not a problem anymore, right? Okay, good. I see your answers there. Ulatimir, Javier, good ones. Okay. Thank you, Pedro, Ivan, Conrado for participating. I'm going to run that in my test explorer, the Mocha Text Explorer, for it to be visual. I'm going to run these tests, and of course they are failing. Okay, I didn't code anything yet, so they are just failing. All of them are failing because I haven't implemented. Okay, so our job in today's lesson is going to implement as much as we can, maybe half of it, maybe a little less. And you can use that to guide your discovery process about the ballot. Tomorrow, we're going to do scripts. I would pick the things that we are writing today and put in a script file tomorrow. So you see where that's going. And later, we're going to do that in a front end written with React or something, TypeScript. So it's all going to be part of a series of 2-3 weeks of content in this same path, in the same direction. Okay. So let's start with something very simple. Let me see what I have suggested first, because I guess I'm going to do the second one first. Completing a test scenario. Okay. Let's do this chairperson thing first, because we understand that already, right? We have this smart contract with a lot of new syntax. This is short stuff. This address is okay, but the mapping, it's new for us. The array is new for us. This by32 is new for us. So let's complete one thing first. That would be the test scenario for the chairperson, because we saw that yesterday. You did test this in the weekend, right? What happens when you deploy your Hello World? Have the owner, remember? And if you're not the owner, things fails and all. You tested that this weekend. So I'm going to pick this example for today. I'm going to do this test scenario here on the line 23. Okay. Let me clear the state of the tests. I guess it's going to clear automatically now. So I'm going to do this test scenario here for the line 24. Okay. So how to pick the smart contract, how to import the smart contract in Solidity from Solidity to TypeScript? Is it possible to import Ballot from the contracts Ballot.sol inside the TypeScript? Is it possible? It's not possible to work with the Solidity file directly inside a TypeScript file. Those are totally different things that are working in totally different worlds. Don't communicate themselves. I need to do something to connect those two worlds, right? Okay. Lauren, do you want to ask first, or you want to answer something?
No, it's a question. Once we have set up the .sol and .ts files, I use VS Code and I try to run the test. And on your side, you had a lot of errors. On my side, it's totally empty. Hello?
Oh, sorry, I was muted. Did you put the Ballot.ts inside tests?
No, I run tests before inputting your line.
No, did you put this ballot.ts here, this file, inside the folder tests?
Let me check. I go to Finder. On test, there is a ballot.ts file with.
And in contracts, you have the Ballot.sol, right?
Let me check. Yeah, I have the Ballot.sol.
Okay, and then you refresh the
Oh.
tests here.
So it's not the same software. It's VS Code. So I go on the bottom. It is written testing, and then I refresh, and then I click on run test.
Okay, but are you able to see all of these?
No, exactly. That's my point.
Okay, maybe you don't have the mock rc.json.
No, I don't have it, but I thought I should have it once we copy paste from the previous project, no?
It happens very often, Laurent. It's not your fault, but some explorers, like the Finder on Mac or the
Okay.
default configuration of the file explorer, they hide the hidden files. So
Okay.
the
So
dot
if we copy
before,
paste, we don't have it, right?
yeah, this happens very often. Okay.
Okay, so I guess I'm not the only one then.
Probably not. Yes,
Okay,
I
fine.
told that, but it's a lot to pay attention. Okay.
Okay.
Pedro, you have a question? Something to add here?
No, it was to answer your question, but if they have questions, I can answer later.
Okay. Yeah, we're going to use something that had 3 letters here to bridge the gap between those 2 words. Okay, maybe you want to answer that, Pedro. Okay.
No, I thought you wanted to use that line of code like await VM.deploy contract.
Exactly. And you remember what is going to be used for communicating, for creating this environment? 3 letters. It's not the EVM, something else.
To create the environment, I think it runs on Hard Hat.
Hard Hat runtime environment, correct.
Oh, okay. Yeah, it runs on
Okay.
Hard Hat and it communicates
HRE.
with JSON RPC.
Wonderful. Yes, we're going to do exactly that now. Or the answer there in the chat too. Ivan, I saw you raised your hand a while ago. You want to ask something or add something?
Just to the previous question that the cache folder, for example, in my case, was not updated, and it contains still the old tests from Ballot.sol. As soon as I deleted solidity files cache JSON and then compiled, then suddenly, again, the tests are the correct ones, which are repeated.
Okay. Yes, I do suggest you to do a cleanup because of that. You clean and we're good to go. So for us to create that link between those 2 words, we can't just import the Solidity file here. We gotta deploy it in this test environment and then test it there. Okay, it's like a workbench or something like that. And there are some classes, some functions from VM that we can use for that. VM alone, it's a little tricky to work. You need to give the API, the bytecode of the smart contract and blah, blah, blah. But VM with Hard Hat, it's super easy. Whenever you are using Hard Hat, for example, to deploy a smart contract with VM, you can just like deploy, let me, just 1 second, pick the correct link here. I had that in this link in last lessons material. So whenever you want to deploy a smart contract, we're not going to use this ignition model, whatever. We're going to use VM. I should have this explanation somewhere. For us to call functions like deploy contract, pick the signers, pick the provider like we did yesterday, in a much more efficient way than using VM directly. Okay, so we're going to communicate with that Hard Hat runtime environment using TypeScript inside Hard Hat. Okay. Laurent, you want to ask a follow-up question before we proceed?
No, my question is, do we expect other files to miss when we copy paste the structure, or it was basically the mocharc JSON file, which is the usual suspect?
This one?
Yeah, is it the only one we should expect to miss when we copy paste, or should
The dot and then the dot ignore too. Those two.
Okay, so every file which starts with a dot.
Exactly.
Okay, thanks.
So let's begin. I do have the explanation here in the README, how we're going to do this configuration, the fixture. Now, let me do it in a single test first, in a single use case here without the fixture, and then I explain why we're going to do the fixture. Okay. So I'm going to create this object called ballot contract by using this command called deploy contract. This command deploy contract is from hard-hat. I know we are using it in VM. This is a little tricky, but this is a deploy contract object that hard-hat is injecting on VM. So correct contract. Pick the correct VM. I guess as such is not working well. I do have this link on yesterday's lesson. I'll pick it real quick. This one of these references here, okay, using VM. Okay, sorry about that. I should copy this reference too. So using VM, hard-hat VM, you have this method called deploy contract. Okay, contracts here. We have this method called deploy contract, where you just need to pass the artifact name for it, and hard-hat is going to figure out the ABI, is going to figure out the bytecode that it needs to be passed. Okay, tomorrow we're going to use VM directly, and we're going to see that you need to pass more things for it, but using hard-hat is super easy. Vladimir, thank you for sharing that in the chat too. It took me a while to find. I'm surprised to see that the documentation is not working. So we are going to do this command here, ballot contract equal to VM.deploy contract, passing a name for the ballot and the parameters. Okay, I'm going to skip the explanation of the parameters for now because it's going to be more visible in the next text, in the next test that we're going to do. But for now, just imagine that you need to pass those two things, the name of the smart contract and the parameters to deploy it. Okay, so I'm going to copy this line of code, and I promise that I'm going to explain about these parameters just in a while. Okay. So I'm going to deploy this ballot contract like this. Yes, you should compile your smart contracts before. Okay, like go here, compile the project. You should have your artifacts here. This artifacts folder is very important. Okay. So do compile your smart contracts first. We are going to deploy this contract, name it ballot. Okay, the name that you put here is very important. If you put the wrong name like potato, and if you try to run this, you're going to have an error because there is no contract named potato here, okay? Artifact, potato is not working. So hard-hat is going to try and search for that. If I pass ballot, it works. I do have a smart contract called ballot there. Okay. So look, the green mark here, it works. I'm going to explain about these parameters later, okay? Forget about the parameters right now. I'm deploying this smart contract called ballot. And whenever I want to check something, I can use the read function. I can pick the ballot contract that I have here. If I put a dot, I'm going to see all of the members here. I have IBI, address, estimate, guess, read, simulate, write. This is the IntelliSense from TypeScript. You can see what I have there. I'm going to call read. Okay. Then I'm going to put another dot to see what I can read in that smart contract. I can read the chairperson, the proposals, the voters, the winner name, and the winning proposal. Okay. I'm going to pick the chairperson. Okay. And this is a function. So I'm going to call with this parenthesis. Okay. We are coding line 27 very, very slowly here. Okay. Yes, Pedro?
But reads directly from the blockchain from Hard Hat, yeah.
Yeah, read from the state of the blockchain that we have inside the Hard Hat runtime environment.
It's not like using a view function. We literally go there and look at Hard Hat's value, right?
Yeah.
Okay.
And if the blockchain is offline, you're not going to see anything. And if the value is updated, it's not going to bind here. We're going to see all of that. This is why I like that experimentation.
But Hard Hat is offline, is in our computer.
When we run the test, it boots a blockchain very quickly and destroy that blockchain very quickly too.
Yeah.
So we don't need to run it beforehand. Okay. And this chairperson call is going to return something that is a promise. Let's see that. Let me do like a const here, const chairperson equal to this. And then I'm going to do something like a console log chairperson. Okay. I can also place a breakpoint. Okay, that would work too. It's just that if you don't have the Mocha Test Explorer working, you could do those console logs by doing it only, and then you run with the terminal. npx hard test. It's going to run only that test. Okay. When the contract is deployed, I have this promise pending. See, let me place a breakpoint and show that with the and show that with the Mocha Test Explorer too. Let me debug this test. And I'm going to hover my mouse over the chairperson, and I'm going to see that there is a promise pending, you see? This is because of the asynchronous logic that we have here. This might take a while for completing, so TypeScript doesn't know what to do in the meantime. It's going to keep going, okay? You got to specify for it. Hey, I'll wait for this answer before doing anything else. So if I put this word, I'll wait here, TypeScript is going to stop whatever the computer is doing that thread, and it's going to sit and wait. It's going to run the clocks. Okay, not yet, not yet, not yet, not yet, not yet. Okay, now I have it. Okay. Otherwise, TypeScript is very dumb. You gotta say wait for this. It doesn't know actually. It's not that it's dumb. It doesn't know. It's going to keep doing the things that you told it. It's going to thumbs up. Okay, you asked me to do this, and then I ask it, and then it keeps doing the things that it has in line by line. So you gotta say, hey boy, stop and wait, breathe, have a while, take a coffee. And when this answer comes, you use it, and then you can use it inside your code. If I do that now, if I run this test now, click here and debug. You don't need to modify the smart contract here, so you don't need to compile again. But every time that you modify the smart contract, you would need to compile. So the chairperson now is an address. It's not that promise that is pending anymore. It's an address, you see? And we saw this address before, somewhere. Okay. Arda, you want to ask a question before I proceed?
Sorry, I was going to ask, should we await, but you already answered that. Thank you.
Okay, good. You saw that coming, right? So this kind of test structure can show you those complexities or things. If you're new to TypeScript, you might not know about this await stuff, about this objects and calls. So this can guide you very, very slowly on what is happening here. Okay. So now I can pick this chairperson here. For me to check if the chairperson is correct, I need to pick this other object, the wallet clients. I need to use this line here. The get wallet clients, if you go for the documentation, get wallet clients is going to, I should have it there somewhere. We did that in the accounts task. Remember, I don't see it here in this documentation, but we saw that this wallet client is going to be the Ethereum accounts that would have ability to sign transactions and pay for transactions inside the hot runtime environment because they are pre-funded there. They are not pre-funded in testnets, okay, but in the HRE they are pre-funded. So I can do this command: get wallet clients. Let me copy this and let me put it inside my code here. Okay, so that I have these two. Let me place a breakpoint here. And let me debug that again to show what is happening, to stop time and show what is happening. Where is my breakpoint? Here. So I have this chairperson that is a string that starts with 0xF39F. Well, I do have this deployer that is an object which has a member account. It's another object which has this address 0xF in lowercase, 39F in lowercase, D in lowercase. You see this? Account address, we have this string. And the chairperson, we have this string quite similar. It's just that the casing is different, you see? Chairperson here, deployer, account here. Okay, so how to check this test to see if it's passing correctly? I should expect what to equal to what? Pedro, want to take a guess here?
Deployer and chairperson.
Expect the deployer to equal to the chairperson. This? Well, let's try. I like this kind of testing environment because we can just testing. We don't need to spend too much brain cells on thinking. We can just throw there and test. And it seems that it failed because we expected this object to equal to this string.
No, but the account object with the address. So
Okay.
it's probably deployer dot something dot something.
Deployer dot account dot address. This?
Yeah.
Let's test. It's harmless. Be used to that, people. Test something, see if it's failing and all, and then you're going to understand. The test is still failing because we expected this to be equal to this. It's the same suggestion you did.
It's the casing now.
Right?
Now it's the casing.
Now it's the casing, you see? So we need to pick chairperson, and that here it is in upper cases because of it's just a checksum that they implement, okay, people. And then I make it to lower case. Now it should pass.
But why don't you put both? Can you just assume that the deployer account address is already lowercase?
Yeah, for now, it's passing. Okay, so we could put both. The most important thing here is to show how this testing environment can guide you to understand the things that are happening. Okay, so I pick this thing, it's uppercase, it's an object. I need to pick that member of that object. Now, this is the most important thing for us to learn today. So we debugged, we tested, we got it wrong in the first time, then we put the object, it was still wrong because of the casing. Now we pick lowercase, now this test is passing. When I run it here, it should be passing, it should be working, should be green. It is working. Okay. The visuals might be a little different because of Cursor and VS Code. They are fork, Cursor is fork from VS Code, but they don't look exactly the same. But you should have the same result when running this test there on your side. Okay. Lauren, do you have a question?
Yes. When I run the debug, when I try to debug like you, putting a red point, and I select the chairperson, I don't see a value. I see a statement like const chairperson equals 0x dollars, blah, blah.
Okay.
I
You
don't
need
see
to put
the value itself.
You need to put the breakpoint after that line.
Uh-huh.
Not in the line. You need to put the breakpoint after the line, so it calculates this line, and then you stop later.
And
not
why
before.
you put the red point or the break? How is it called? Break point?
Breakpoint, yes.
What do you do? You click and you rerun the test? What is the
Yes.
procedure exactly? Sorry to ask.
No worries. That's good. You click the before the line, like if the line is here, you move your mouse a little to the left, you click here,
Yeah.
and then you do a right click and debug the test on this exact test case, and it's going to stop there, okay, for you to view the things that are happening.
I don't see it. I see add breakpoint, add conditional breakpoint, and so on and so forth.
What do you mean? Like when you click here?
I need to click on the red button?
No red button. Look, you see those lines here, 23, 24,
Yes,
25,
yes.
26. You move your mouse a little to the left, and then you click. It's going to create that red dot here, okay?
Yeah. Oh, this is clear. That's not my question, sorry. Once I put the red symbol, the red button, how do I launch the debug test?
Okay, there are two ways for that. So you can either find the two arrows for the test, do a right click and click on debug test, or you can go here for the testing pane, select from this list the test that you want to run, and click in this second play arrow with the little bug here, the cockroach with the play, something like that.
Okay, I think that I see like a circle which is turning, so it seems that something is running. I stop the test to rerun. Sorry.
Okay, but if you click here, it should work, right?
I don't have the same interface, so yeah, no, I don't see what you see.
If you open that with VS Code,
yeah, with VS Code, yeah,
you should have a very similar interface with this Flask in the left side with quite the same thing, right? Let me pick here. Wait, I should have it somewhere.
I think, Matteo, that I'm running a test. How should I stop the test first?
Not that I had this extension here, Mocha Test Explorer. Yeah, it's not showing here for me, but you should see the same interface. VS Code and Cursor, they should look very same here. If you have a test going, let me run it here. If you have a test going, you should see a pane like this, you see, in the top,
Okay.
and then you can disconnect.
Okay. So now
Shift
now
F5.
it is stopped. So I have the red the breakpoint, sorry, or the break button. I don't know. And okay. So I click on the click to run test or debug test.
Debug test. With the bug, it should stop in that breakpoint. Okay. And that on VS Code. If it's two different people, you tell me, like, if VS Code is not
Okay,
working like
now it
push.
is working, Matheus. Okay, thanks. Now I see the value 0x. Sorry for the others, but
No worries, no
I
worries.
was feeling a bit lost. Sorry.
Let me check this. Where's my extension? Test Explorer. No, I see it here. Testing. Okay, so it should be very similar. Look here, Laurent. This is VS Code with the Test Explorer. You should see an interface almost equal to what I have in Cursor, right? Something like this, right?
No, I don't see it. I will try to find later. I don't want to slow down the lesson.
Okay. Anyone else with this problem with the VS Code? You should be using this testing.
I have that same
station.
interface, and I'm on VS Code. I just go to testing. I go up there. I reload, and that would appear.
Okay. Yeah. Sometimes you might have problems with all the testing. Like if you pick all the Test Explorer now, it might behave very different. So Mocha Test Explorer is going to be exactly equal with what I'm using here. Okay. Using Cursor and using VS Code is the same thing, like this, the same experience for that extension. Okay.
Okay, thanks.
Okay. Any other questions here about this test? Is set the deployer address as a chairperson? Okay, we have Browns with a hand raised. You have a question here, Browns? The code on VS Code. It says here I'm using Cursor. Okay. So people, what we are going to do now is to create people, if you still have questions, feel free to raise your hand again. I'm going to lower here just to organize. What we're going to do now is to organize this test with this fixture function so that I don't repeat my code again and again. Because if I'm going to do all the tests now, for example, it has 0 volts for all the proposals. Okay, so let's deploy the smart contract again. It has all the provided proposals. Okay, so let's deploy the smart contract again. You see, I'm repeating my code again and again and again and again and again and again, which is not good. Okay, so what we're going to do this is, instead of repeating in all of the definitions, we're going to put all of these contract creation code and setup code inside a fixture, inside a function called deploy contract or setup contracts or setup test, whatever name you want to give of it. And I'm going to export all of the things that I'm defining in a return statement. Okay. So we're going to do that. We're going to copy this deploy contract function and we're going to paste it here. This deploy contract here. Okay. And instead of calling it again and again and again in every test, we are going to use this functionality of load fixture. That is a very useful functionality where I set the desired state of the network before the test, and then we're going to take a snapshot of the blockchain, a picture, a saved state, and every time that I call it again, for every subsequent call, we are going to return the blockchain to that snapshot state without doing all of the operations again. So it's very quick. I do something, I go back in time. I do something else, I go back in time. I do something else, and I go back in time. I don't need to create all of the setup again and again. Okay. So I'm going to call this fixture with the function deploy contract on every test that I would need to use those things. For example, instead of deploying the contract and picking the deployer, I would just pick those two from this function load fixture, like this, that I have here. I'm going to pick the ballot contract and the deployer from the fixture. So when I run this, I'm going to have the same result. I'm going to have the same output. The contract is going to be the same. The deployer is going to be the same. But now I have this fixture function to define things for me, instead of doing that again and again every time that I wanted to test something. Okay.
I think you stopped sharing your screen.
Am I?
I see the screen.
Yeah, maybe it's your internet connection lets me.
Okay.
In fact, Zoom is very buggy. I was listening to some webinars last year and then saw that it's very common to have things bugging with Zoom. Let's see the questions here in the chat. Every time we modify the test, we don't need to compile again the test, only when we change the smart contracts, okay? Arda, you want to ask something?
Yes, so when we return something like this in the fixture in TypeScript, it doesn't return it as an ordered list, but just a set so that I can extract the names, because I see you like in the fixture we're returning 4 things, right?
Yes.
But in line 30 or 29, we're just extracting the ballot contract and the deployer.
Yes, we're deconstructing this object. So we are
Yeah.
going to ignore all of the other members, and we're going to pick just the object of ballot contract and deployer from this feature. Okay.
All right. So the feature return acts something like a structure.
Yeah, we have those two syntaxes in TypeScript. This is an object with the curly brackets, and then you pick things by the name. But also it happens with arrays. So for example, this object, I'm picking deployer as the first member of this array, other account as the second name. I could pick like a third account as a third member, and then I could do something like this. All other accounts would come in this object. See, so it is possible in TypeScript. Let me see if I debug something.
And then
And
these
then
all other accounts would be accessed with from starting from 0 as an array.
all other. So it didn't call the fixture. Sorry about that. I placed a bad breakpoint. Let me do this. Here. So deployer is going to be the first account, you see? Other account is going to be the second. Third account is going to be the third. And all other accounts is going to be one array. I should be able to see it here. It's going to be an array with 17 other accounts, you see?
Okay.
So this is, yeah.
Is there a way we can learn the length of all the other accounts?
It's 17 here.
Yeah, but like real time, not while debugging. After
Okay. No, yeah, and then you would need to know the thing that you're asking there, the wallet clients, how many they come, you know.
Oh, okay. So get wallet clients can tell me that somehow.
Yeah, but this is An array. Okay, it's different from the if you're thinking on the object, the tuple that returns when you.
I got that part.
Okay, good,
All right, thank you.
wonderful. Yeah, again, I'm stressing on that people because we are not going to have time to go over this whole test. It's normal, every bootcamp, we don't have time to go over all of this test. But I want you to use this sandbox testing environment as your teacher. So anything that you want to discover, you want to test, you want to see if it works and all, you can go here and test. I want to get you used to that. Because in Web3, there is too much of promises, too much of marketing, too much of telling. And when you test things out, some things they just don't work the way that people are saying. Oh, my blockchain is super scalable, thousands of transactions per second. And you go there, you do 10 transactions and it breaks. So I want to get you used to see things out there. Right now we're using very vetted and good things on the documentation, okay, and we are learning. But in the future, you can pick like token standards, you can pick protocols, SDKs and all, and put inside the same sandbox, inside the same technique, and discover things by yourself. You go there, you explore the technicalities of this, the syntax, as you call the documentation, and then you see what works and what doesn't work. Okay, but this is why I want to stress on this technique. So the technique is much more important than understanding Ballot here, and we are going to see how it can teach us, how it can guide us to what we are doing. Okay. So more questions about the fixture, deploy contract fixture. We're returning an object, and then in every next test that we do, we can inherit that object. Okay. Let's do this first test. It has all the provider proposals. So for this, I want to inherit just the Ballot contract. I don't need the accounts. Okay. It has all the provider proposals. I'm going to inherit this. And I'm going to add some tests on top of this. Okay. Ballot contract. It has all the provided proposals. Okay, I'm going to add some tests, just like we did in this test here. I'm quite sure it was passing, because it just timed it out. Let's see. Yes, it was passing. So I'm going to do something very similar. I'm going to copy this. And it's going to be wrong, but I'm going to ask your help for guiding me. Const proposals equals to await the Ballot contract read proposals. And I expect these proposals to equal to my proposals array that I have here. What is the rationale here? When I'm deploying that smart contract, now let's look at this parameter that I'm passing. I'm passing an array of proposals here for that smart contract here into the constructor parameter. And we are creating an array of these proposals here inside the constructor, inside this loop. So it's the same thing as the chairperson. In the constructor, I'm setting this chairperson, and then I test, and it works. Line 29 to 33. It's working. Why is not the same thing with the proposals? The proposal is the same thing. I set it, I pass it in the parameters, and then I set it in the constructor. But here we are having this error. This is going to take 10 minutes of back and forth to explain. So I need you to pay a lot of attention to go through this. Okay. Pedro, you want to ask something before that?
Can you just compare arrays like that in TypeScript? You don't have to do element-wise comparison?
We can't even get the array from the solidity. We're going to see that now.
Oh, okay.
Okay. Give me 10 seconds, people. Be right back in 10 seconds. Okay, I'm back. Solving a background noise here. So this array of proposals is different from this chairperson. I know that we're doing the same thing. We set the proposals, then we want to get them. But here we have a lot of complexities to go through. First complexity. In the EVM, not only Solidity, but in the EVM, there is no way for getting the whole array from the blockchain. This array could have thousands of members, and you can't return it all in one go. I would need to pick proposal by proposal. So for example, the proposal 0 would be picking the proposal at the number 0. I need to pass it like this. And then I would see if the proposal 0 equals to the first member of the proposal. Okay, I'm passing a parameter for this call, getting the proposal at the position 0, 0n, because it's a big number. We're going to see a lot of that next week. Don't worry about big numbers now. And I'm going to check if proposal 0 is equal to that one. And then I can do the same thing with proposal 1 and with proposal 2. You got the idea, right? So I need to check position by position. How to check the whole array? I wouldn't need to go for the whole position of the array to check it out. A while loop and all, okay? That is true. So the first problem, arrays. In Solidity, we cannot get arrays directly. Whenever we create a public array, like this one, public array, we don't have a getter for the whole array. We have a getter for the positions of that array, okay? Complexity number 1 is this. But also, this is not going to work. We're going to go back and forth here for more 8 minutes or so, because now we have the second complexity. We expected an object to equal to proposal 1. An object. What is that? Let's debug. Let me put a breakpoint here. Let's debug. We're going to see that this proposal at the position 0, it's not just a string. It's actually an object, a structure object, defined as a type of proposal here. And the type of proposal is a complex type defined in the smart contract itself, which has 2 members, similar to an object, similar to a class, okay? But in fact, it's very different, but we're going to treat it very similarly here. In this struct, we have 2 members. We're going to see one member of position 0, that is this string, and the second member at position 1, that is a big number. This is a structure. It's a structured data in the blockchain carrying 2 positions exactly as I have defined here, 17 and 18. Okay, those 2 positions there. Okay. Questions, Pedro?
No, it was to say what you said, that the
Yeah,
proposals,
wonderful.
it's the byte
You
array.
studied it. So you see here, there are 2 members, so I cannot compare this object to what I want. What I want is the first
Short name.
member, the name, the short name, right? up to 32 bytes. We're going to see that in the next complexity. We are still in the complexity 2. We don't have an array of strings. We have one array of objects, of structs. So we are learning structs now. That structs are bundled data, bundled object-like things, where we can get different members. So what I want is to compare the name, which is the object 0, okay, object 0 of these proposals. Okay. This is what we want to compare. But still we have a third complexity. Okay, maybe this is the one that you want to speak about, Pedro.
Because you're comparing, I think the proposals in the TypeScript looks like a string, but the name in the Solidity is a fixed size 32 byte array. So
yes.
So you
So they
need
are different.
They are not the same variable type. So you need to
Exactly.
convert the 32 byte array to a string.
You remember, people, everyone here, that you did the string operation with hello world, and then you could put any string there. With these smart contracts, Ballot, they are designed to use a byte 32 that has a limited size. So I don't have a string like proposal 1 here. What I have is a sequence of bytes, like this one, 50, 72, 6F, blah, 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 blah. This is because when we are storing this in the blockchain, I'm passing this text to hex, to hexadecimal. Okay, yes, we did that. If we don't do that, if we try to pass proposals directly, if I try to pass an array of strings directly, this is not going to work. Okay, because the object that I need to pass here, it is an array of bytes 32, not an array of strings. This wouldn't work. I need to pass these proposals to hex first with this comment here. And when comparing, I need to compare converting from hex to string, as I have here in this import line 2 from VM, this utility function. And then I can just do something like this, hex to string, picking the string of proposal 0. It has 32 bytes here. Let me see if I'm doing that correctly. Hex to string, read proposals, and I expect proposal 1. No, wait. No, I was speaking the wrong one. Hex to string, proposal 0. Yes, and I need to pass the size 32. If not, this test is still going to fail because it's going to have a lot of appended zeros, appended nothings. I'm going to show that for you now. So you see proposal 1, but then I have all of those appended zeros here. So I'm going to solve that by fixing the size of that hex to string to 32. Like this. And now this test is going to work. 3 complexities. 1, because I cannot get all the proposals directly from an array. 2nd, because the proposal is not a string directly, it's an object. And 3rd, even when I get the name of the proposal, it's not a string. It's a byte 32 that I need to convert to string before comparing. I would need to do that for the 3 positions. So if I create a loop, this is the code that we have here. If I create a loop, now I can test all of these positions. I can test the position 0, the position 1, the position 2 to see if all of them have the correct string stored there. Okay, so we have just learned about structs, learned about arrays, learned about byte 32 in one single in one single test case. Okay. Yes, Ardo?
So for the proposals, why are we limiting the size to 32 bytes? Because it's the maximum size that can be held in a certain string in a blockchain without breaking.
Yeah, remember the layout of the storage. We did that in lesson 2. Everything comes together eventually. Actually, we did in lesson 3, if I recall it correctly. Here, yes, we saw this thing here, the storage, remember, in the stack. We have in the storage a mapping of 256-bit to 256-bit here. So 256-bit would be 32 bytes. So in each of those storage locations, we can store 32 bytes. So when we have this smart contract storing this string as a byte 32, it can use up to 32 bytes to store the short name. Now we have the definition of this short name, because otherwise I would need more space in the blockchain to store this.
Which is not preferred, right?
Yes, see how those technical details they surface. So it can be easy to get started, yes, but you also need to look under the hood and understand what is happening in the architecture level when we encounter this kind of techniques here. Okay. Is that clear for everyone? Right, 32 thing here, this test. Today's region here again. Okay, we're doing this test here, first one. Okay, you should have the hex to string imported in line number 2. Okay.
Yeah, this is a question. Once we are in the debug mode and I try to print something, for example, like proposal 0 in debug console, it is possible somehow to import all the input from the file to use it
It is,
in
but
the debug.
it's a little more tricky because what you have is like the hex to string is actually a JavaScript library. Here we're bringing it inside this object with TypeScript is something called a Emac script.
Okay.
It is defined here in the TypeScript configurations. So ES 2020 actually. So here we don't have this namespace for hex to string indeed when we are running. Well, we have the JavaScript version of it. So when you are working with TypeScript, you are working with some illusions, some mirages, because what is happening out there is the transpilation of JavaScript. So when you are running the debug, you don't have this whole help from TypeScript to use hex to string and define it. It's not defined there, okay? So it's a little more tricky. But when you code that structure with TypeScript, then everything gets organized for you, okay?
Okay, thanks.
TypeScript is a superset on JavaScript, so you are coding code to code for you, something like that. We have 5 minutes to do one extra. I'm going to explain about mappings. Okay. I'm going to do this second test scenario that has 0 votes for all the proposals. Okay. Actually, this is not a mapping. Let me see. Actually, this one is going to be the mapping. This has 0 votes for all the proposals. It's just a copy from this one. But instead of checking the name, it would check the member proposals, position 1. That would be the votes. Okay, and it should be 0 in every a position, it shouldn't start, the ballot shouldn't be deployed with more votes than 0, right? So let's skip this test and let's go for this one where I'm going to explain about mappings. It should set the voting weight for the chairperson as 1. We have an object here, object like a struct voter, that for each address inside the blockchain, I'm going to have a voter with a voting weight, a Boolean indicated whether it has voted or not, an address indicating whether it has delegated or not for someone else, and the proposal index that it has voted for. And I have a mapping that for every address in the blockchain, I'm going to have 1 voter. Okay. This mapping is different from array. Array would go from a number, a uint, to a proposal. An array would go always from number to object, number to object. But a mapping can go from anything to anything. Let me show this test here to explain that. It sets the voting weight of the chairperson as 1. So this mapping can read the voters at the address chairperson. Yes, it's not the voters at the number 0. It's not the voters at the position 0. No, it is the voters at the position chairperson. So it's like a key value map. I can have a string as a key. I can have a number as a key. I can have a Boolean as a key. I can have another mapping as a key. And then I can map that to a value. So even though I did not define this, I did not define this initial value, it can answer. Okay. For example, this is the chairperson voter. Okay. And let me pick another voter. Const random voter. That is going to be await the ballot contract read voters, but at another address. For example, in the ballot contract address. Okay. Can be any address, can be the 0 address, can be my address, can be any random object that I get from here. And let me show how that would go. Have 1 more minute. Any question that I make for a mapping is going to answer. I can ask any address now for these voters. The chairperson voter is this correct object with the weight equal to 1, voted equal to false, delegate equal to the 0 address, the vote index is 0. Okay, yes. But this random voter, it answered. If I pick an array out of bounds, it's going to give an error. But with the mapping, no. The mapping, I can ask literally any address in the network, any address. For example, what is the voter for the 0 address? 0 voter. Even if I did not define the voter position for the 0 address, I don't have it in the smart contract. I don't have any initial declaration of that voter, even though it's going to answer. It's not going to give like an out of bounds error. Look here, I have a voter for the 0 address. So this is the difference from array to mapping. Array is going to answer regardless of what you ask, it's going to answer there. And if there is nothing there, it's going to answer like all zeros, all the default values for all of the things. A Boolean is going to be false, a string is going to be empty, a number is going to be 0. But if there is something there, like the chairperson voter, it's going to answer correctly. It's going to give the information that it was there. Okay. If I take this out, this test should be passing now. I can have this first block of tests, this first describe of the ballot deployment, correct, okay? And all of the other ones, they are going to fail. Don't have these working for today. It is a small homework for you if you want, okay, optional. Try to complete as many as possible when you have the time, because we are going to use these tomorrow for writing the scripts, okay? For tomorrow, you should have your .env file sorted with a wallet, with one RPC connection, okay? And you should have one in the testnet for running tomorrow's lesson, okay? Because we're going to deploy a smart contract when we're going to interact in the public testnet, okay? Very important. For today, that's it. I hope that you have enjoyed. Any questions, please feel free to ping me on Discord to open issues on GitHub, okay? And we start from here tomorrow.